Hello, welcome back. Today, we want to talk about properties of logarithms. So these are some very useful properties logarithms have. We have to understand what they are and then how to actually use them. Our goals would be to understand these properties. We want to be able to use these properties to evaluate logarithms. In some cases, many cases we use a calculator, but often we can actually find, in some cases, we can find the exact value without using a calculator by understanding these properties. And then also want to be able to use the properties of logarithms to expand logarithmic expressions or to write logarithmic expressions as a single logarithm. We'll explain what that means here in a moment. So first off, let's talk about the first few properties of logarithm. And here, we're starting with b. We're going to write our base as the letter b, but b is positive and b is not 0. B is not 1. We've seen this before. So the first one just says log base b of b is equal to 1. So let's kind of look at some examples, specific examples of some of these. Okay. For example, what that would say would be that do an example, let's say log base 2 of 2 is equal to 1. Okay. Why is that true? Well, basically, logs and exponents kind of undo each other. Okay. They kind of cancel each other out since they're inverses. So this log of base 2 basically just cancels each other out. And what we're left with is 1. So here, log of base 2, and think of that way, this cancels out base 2. Okay. Now, let's take a look at the second one. Now, this one, it says log base b of 1 equals 0. So I'll pick another log. So let's say I have log of about 8, okay, of 1 equals 0, right? Now, this is just one example, but the reason this is true in part is because basically all logs and basically mean all logarithmic expressions, I'll write as all logs have 1, 0 as the x-intercept from the graph. And so that's basically what that's showing. You plug in 1 for x, you get 0. Now, property number 3. Actually, property number 3, it says log base b of x equals x. So let's do, how about we do log base 10, or just log of 10 to the x is just x, okay? As once again, because logs and exponents of the same base cancel. What happens, these cancel each other out, and we're just left with x. And actually, number 1, this is kind of number 1 is kind of a result of number 3 in the sense that if all this is being 2 to the first, which it is, then the exponent is just 1. Okay. And then property number 4 is kind of like property number 3, just restated in terms of the base. At this time, let's use natural log. So we use e to the natural log of x. That's also just equal to x for the same reason. Here I'll just say same reason as number 3, okay? Because logs and exponents of the same base cancel each other out. Whether we're talking about the log of the exponent or the exponent of the log, if they're the same base, they cancel each other out. Okay, so that's often a useful property. Actually, you can kind of use that property in solving logarithmic and exponential equations. Now, let's talk about the next set of properties. So this says for positive numbers m and n, because remember we can't take the log of a negative number or 0, so that m and n have to be positive, and some real number r. That if you have log any base of m times n, you're taking the log of the whole thing, we can expand that using plus. So that becomes log of m plus log of n. This is true once again for any base, and as long as m and n are both positive numbers. In a similar way, if we're dividing m and n of any base, then it's log base of m minus log base n, or you think of it as log of the numerator minus the log of the denominator. That's another property. Okay, and once again, this is true as long as you're either multiplying or dividing. The other, number 3, is also interesting. it just says that if we're taking the log of some m, which itself is raised to some exponent r, we can actually bring the r out front. Okay, so which makes it a lot easier to simplify and to solve without having to avoid possibly having a really large number to work with by raising m to the r power. Once again, r was a real number. And then finally, this last one, we can actually rewrite b of r just in this form right here. Okay, and in some cases, that's useful. All right, so we just write b the r like this, because you remember what would happen then is, in fact, let me go ahead and explain that one, then we'll take a look at the others. Let's come back over here and draw a line. All right, so let's look at this one. So this property. So we have b to the r is equal to e to the r ln of b. Now, why does this work? And actually, excuse me, I realize I need more. I didn't put enough space. All right, you have to give me a moment here. I'm gonna have to do something I didn't want to have to do. Okay. Make sure I have enough space. I should have done before. Now let's come back up here and I'll just copy that. Okay, so I have this property. Now, what does this mean or why does this work? Well, let's think about this. We're actually going to use this property above it. Then e, I can take this exponent, I take this number up front and make it the exponent of b. I can write this as e, the natural log of b to the r. Then once again, these cancel each other out. I'm left with just b to the r. Okay, now that's something we can do. Some cases it may be useful, in many cases it won't be. That is something that is valid. Okay. Also, one more thing I want to point out before we go on is that be careful when you're doing, especially this property here, make sure you don't confuse it for this. Okay, here within the log, we're taking the log of m times n, the product of m and n. Here, if you have m plus n or m minus n, you can't expand it. Okay, so essentially you think of it, you can't think of it as, you can't distribute the logs. Okay, so this is not true. So if you have within the parentheses, you're taking the log of m plus n or m minus n, it doesn't expand. Only if it's m times n. Just keep that in mind, because that can be an easy mistake to make. Now, let's look at a few examples of first expanding logarithms and then basically contract them, writing them as one. So what I want to do here is expand. My direction would be expand using the properties of logarithms. Okay, so number one. So we have this. The log, let me write that in G a little bit better. The log of, remember that's log base 10, it just says log of x times y to the fifth. Okay, so what I mean by expanding is, well, first off, this is a product. This is x times y to the fifth. So we can use this first property. Okay, and so we can write that using this first property as the log of x plus log of y to the fifth. So since that was a product between x times y to the fifth, we can separate them this way. Then also, we can also take this exponent and bring it down front. And now I can finally write this as log of x plus 5 times the log of y. Maybe you're wondering, why would you do this? Well, often it's simpler to, there are different, some applications we can use. Sometimes it may be simpler just to add things like this than is to multiply them. And also there's some things, and sometimes you can actually graph exponential expressions, essentially using logs, to essentially make straight lines out of something that's not a straight line, just in the log, what's called a log scale. And oftentimes that can be helpful to to understand data. And also, if those of you who are taking calculus, you can actually use less log idea, then help you take the derivative. So that's something, if you heard of a derivative, if not, that's okay. But if you take calculus, you'll see that. Okay, that's number one. Number two, let's do a similar thing. This time, let's say we have log base 3 of this expression. So it's a fraction, x squared times y equals or over z cubed. So once again, I want to expand this out. Base expand until you can't do anymore. Also, I should have mentioned this. Look at each one of our expressions. There's nothing else. I can't use these properties to simplify it anymore. Okay, so I'm done. Now here, this time I'm taking log base 3 this time, and it's a fraction. So what the second property says, if you have a fraction, you think of it, base is the log, whatever log base it is, log base 3 of the numerator, which is x squared times y, then minus log base 3 of the denominator, z cubed. Of course, the order here, since it's a fraction, the order here is important. So it's basically the log of the numerator minus the log of the denominator. Okay, so looking at this, we can say, what else can we do using those same properties? Well, here, I can expand this, have a product of x squared times y, and here I can bring this exponent down front. And so next, I'll have, I expand this product, I'll have log base 3 of x squared plus log base 3 of y. Then here, I bring the exponent down front using this third property, and have minus 3 times log of z. Okay. Now look what we have left. Notice I can't do anything else with, oops, I forgot, sorry, my 3. Also, it's really important. Make sure you have the right base there. I can't do anything else with this or with this, but I can here, like I did in the case of the z, I can bring this exponent down front. And finally, I have 2 times log base 3 of x plus log base 3 of y minus 3 times the log base 3 of z. Now I'm done, because we look at each one of our log expressions, there's nothing else I can do using these properties that I can expand in any way. Okay, so that's the idea of expanding an expression using logarithms. Now, we want to go backwards, do the same thing. Now we want to write expression as a single logarithm. Okay, I want to write the expression as a single logarithm. So what that means basically is taking this properties we just used, what we just did, and going in reverse. So let's look at a couple examples of that. Number one, let's say I have 2 times ln. Remember, ln is the log base e, ln of x minus I'm looking to see what I wrote here. Okay, minus 1/3 ln y plus ln z. Okay, so 2 times the natural log of x minus 1/3 times the natural log of the y plus the natural log of z. Okay, now first, one thing you make sure you notice as well, to do this, write as one single logarithm, they all have to have the same base. So let me kind of put that in parentheses here. So must have the same bases. All the logarithmic expressions have to have the same bases, otherwise we can't combine them. Now, so first thing I want to do, if you notice, go back to the one we just did. One of the last things we did was to bring the exponents down front. Here, that's one of the first thing I want to do. Because actually, before I can combine these, then I actually have to get rid of this exponent or get rid of the coefficient in front. So I'm going to take this and make it the exponent of the x. Then I'm going to take this 1/3 and make it the exponent of the y. And so my first thing will be, so the natural log of x squared minus the natural log of y to the 1/3 and plus the natural log of z. Okay. Now that I've done that, now they're all natural logs. Now they're all a place where I can combine them. So here, think about using order of operations. I want to go in order from left to right. So the first thing I have is a minus. So remember, look at our properties here. What that fits is property number 2. So once again, I have the same logarithmic base, both natural logs. They don't have anything in front of them. Okay, I've gotten rid of the coefficients, made them exponents. Now, since it's minus, I can write this as a fraction, and the order is important. So this is the numerator, this is the denominator. This will be the natural log of x squared divided by y to the 1/3, and then finally plus the natural log of z. Then once again, our goal is write as one logarithm. So what we want is just the natural log of something. And so plus is property number 1. So what I do now is multiply this times this. And so finally what I have then is the natural log of x squared times over y to the 1/3 times z. And you can also just simplify that a bit and just write then finally as the natural log of x squared times z in the numerator over y to the 1/3. Now, so that is writing this as one logarithm. So we have just a single logarithm, like natural log of something. And then if you want to check, you should be able to follow your steps back through and make sure you can actually then expand it to what you got. So if you look, if we expanded this out, then we could expand it first using this. Okay. Let's multiply that times that, and then expand this as a difference, and then bring our exponents down front. So that works. Okay. And number 2, let's say we have this. So we have -7 times the log base 5 of a plus 0.12 times log base 5 of b plus c. Okay, so these are both log base 5s. As I did before, first thing is get rid of your exponents, or you get rid of your coefficients, make them exponents. So I'm going to take this and bring it up with the exponent of that. And this 0.12, make the exponent of this. Now here I'm taking the log of this whole thing. So this is going to be log base 5 of a to the -7 plus log base 5 of b plus c to the 0.12. The whole thing there, b plus c is written with that. Also, this is another good example where I would say, you notice, just looking at this log base 5 of b plus c, I can't expand that. I can't write that as log base 5 of b plus log base 5 of c because this is addition. This fits this. So here, if there's b times c, I could expand it. But here, this is b plus c, I can't do anything with this part. Of course, writing is one logarithm. You would want to do that anyway, even if you could in this case. Okay, so now they're both in the right form. So both just logs of something in the same base logs. Now I can combine them. So since it's plus, it means I'm going to multiply them together inside the logarithm. And so this will be log base 5 of a to the -7 times b plus c to the 0.12. And that's writing it as one logarithm. And once again, if you want to check, make sure you can expand it back out to what you started with. So what we've seen is looked at the properties of logarithms and briefly explained what those properties are and how to use them. And these are also really useful in other applications and also in solving equations, which you may see in another video. Thank you. Have a good day.